Hello. I was in a club the other night and I saw this cute girl, and I wanted to go and chat her up. But I want to say something original and sexy. I gave it a good thought, so I went. I said, "Hi, I'm Vaslis. Did you know that stars die with a big explosion called a supernova? You want to hear more? Yeah, I bet you do." She was very excited, I could tell, because she looked me right in the eyes like that. So I started my sexy story. Okay, imagine a fairly big star, at least 8 times bigger than the sun in our solar system. Stars, when they're young, are full of hydrogen atoms. Inside the core of a star, there is a lot of heat and pressure because of the huge layers of matter on top of it and around it. So the outer layers of the star are pressing the core. Because of this outer pressure, the hydrogen atoms inside the core of the star merge together. Actually, they're having a foursome. Well, scientists call it fusion. So 4 hydrogen atoms merge together to become one. The result is a new atom, 4 times heavier than the hydrogen one, and is called a helium atom. Now, this process takes place in all the core of the star until all hydrogen in it turns into helium. So from a hydrogen core, now the star has a core of helium. But the pressure from the outer layer still continues. So now the helium atom inside the core are having a threesome. So 3 of them squeeze together to produce 1 carbon atom. Again, this process takes place in all the core of the star until all helium in it turns into carbon. But the pressure from the outer layers won't stop. So through this process, the core of the star transforms to a gradually heavier element. So from carbon, it will turn to oxygen, and then neon, and then magnesium, and then silicon, until it finally becomes iron. Okay, iron is strong and rigid, just like me. It won't transform to anything else. But the pressure from the outer layers still continues. So what happens now is the iron atoms can't take the pressure, but they won't transform to anything else either. So they collapse. Well, basically, they're getting destroyed. This destruction of the iron atoms takes place in all the core of the star and results in a huge energy outburst. And that gives birth to the supernova explosion, which blasts the oppressive outer layers of the star far in the universe. At that point, the girl in the club interrupted me, and she said, "Sorry, I'm going to go to the toilet for a second, I'll come back." But she never came back. Oh, well, at least I learned from my mistake. Obviously, I took it too far. I shouldn't have mentioned the foursome. The threesome was all right. I guess it was a bit shy. Thanks for listening.
Samandra, what did you learn from that?
I learnt to go to nightclubs in Greece.
Actually, it's based on a true story.
I suspected as much. Okay, so it left me with a question, which is, when you say the iron actually starts to collapse, so what happens to the iron? How can we still have iron?
Right, okay. Let me real quick remind you that an atom has a nucleus and electrons orbiting around it like that, almost. The nucleus has protons and neutrons. They're all little particles. When I said the iron atoms collapse, actually what collapses is the electrons that orbit around the nucleus of one iron atom. Because of the outer pressure, they cannot maintain the distance from the core, the nucleus, so they fall on it. This collapse of the electrons, well, they strike with the protons, right? If you remember, electrons are negatively charged, and protons are positively charged. Like if you have a battery, the negative and the positive side, yeah? So when they collapse, their charges cancel out, because one is negative, the other one is positive, so they cancel out. So protons turn to neutrons. Neutrons are very similar to protons, they're just slightly bigger, and they have no charge. So that collapse of the electrons is what's caused their huge energy outbursts in the form of neutrino emission. These are little particles and gamma rays. So this collision of the electrons. Yeah.
George, is he right? Is he telling the truth?
Well,
I have no idea. He could be telling me anything.
Yes. In fact, he's telling the truth. And can you tell me what are supernovas useful for in astronomy? I mean, apart from being fabulous things in the sky, what's their application?
Well, I said that before again many times. Actually, we owe our existence to one of them. Like the guy said, all the elements that we know on Earth, 110, whatever, there is no other physical mechanism to create them other than the supernova explosion. So they're getting created at the time of the explosion. The shock wave of the explosion makes the outer layer, the oppressive outer layer, to create all these elements. So they create stars, planets, and other stars.
Quentin.
Vasilis Grigoriadis.